Okay, so we continue the lesson. This is also something that you haven't studied in principle in Math 3C, and then we want to learn about the derivative of sine and cosine functions, and a little bit later about the derivative of the tangent function. Yes. So far, I told you that one of our main goal is to complete this table. So what we have so far, we have a function here, a function, its derivative here, a constant is 0, x to power c is c x to the power of c minus 1, and of course you can calculate the derivative of the square roots and a lot of exercises we had before using this formula. And then we also had some formulas which are generic rules so far. One of them is that if you have a constant multiplied by a function and you want to differentiate it, you just differentiate your function and multiply it by that constant. We have the sum rule. If we have f plus g prime, it becomes f prime plus g prime. We have this difference rule. If we have this, it becomes f prime minus g prime. And then this year we'll also learn about the chain rule, which tells you that if you have this function and you want to differentiate it, this becomes the derivative of f, outer function, calculated at the inner function multiplied by the derivative of the inner function. And we also extensively talked about what is the meaning of these symbols. If you remember, this symbol means first replace and then differentiate. This tells you that first differentiate and then replace. These two are not the same, except for the cases that g prime x is equal to 1. So it means that if g of x is equal to x plus a constant, then they are the same. Okay, so today, we will add two more rules here later as a general rule, but mainly we want to complete the table of derivatives. So the first thing that I want to talk about is if I give you the function f of x to be just sine x, we want to find its derivative. So here I want to put sine x here, and I want to answer this question. Okay, but that is extremely important here. I want to emphasize that x is in radians. Okay, so I will tell you why this is important. Okay, so what we have to do, I want to find the derivative of a function. I don't know anything about its derivative, so there is only one starting point for me, and that is, what is the starting point for this? Because you don't know anything about the derivative of sine, you just want to discover it. So there is only one way to do it, and start from scratch. Yes, you have to use the definition of the derivative. So what you write, f prime of x is equal to what? The limit of f of x plus h minus f of x over h. H goes to 0. This is what I have to calculate, this limit. And then hopefully you have now enough experience. So I will copy and paste some parts as usual. And then I have this minus sign. F of x is exactly this function. Okay, but what is f of x plus h? I have to go to my function, replace my input with the new input. So it becomes sine of x plus h. Okay? There is one part in this limit that you are not able to calculate it rigorously. Okay? So I will follow. In this book, Exponent, there is a chapter, there is a part for the students who are interested to know more. In that part, they have calculated those limits that we are going to use here. But because that's not part of the lesson, so let us skip that so that we can keep the time for the parts that we need. Okay, but at least the starting point for the continuation shouldn't be that hard for you. What do you think I will do from now on to calculate this limit? So you see that I have problems, yes. If I send h equals to 0, then the denominator vanishes. And then there is no way that I can get this h out, apparently, to get rid of this h somehow. So this is held captive by this sign, the sine function, so I cannot take it out. So what should I do? or at least what do you do? This should remind you of a formula. Yes? The conjugate pattern will not work. So you mean that you multiply this and by the addition, yes, between them, no? Yes? Addition, addition formula for sine, yes? So what I write, it becomes, do you remember what was addition formula? Sine of this sum of two angles is equal to the sine of the first one multiplied by the cosine of the second one plus the other way around. Sine of the first one multiplied by cosine of the second one. This is what I have written instead of the first term. And then I have minus sine x at the end. F overall divided by h. H goes to 0. But don't get confused here. I have two letters here, x and h, but which one is the variable in this limit? The one that I'm sending it to 0. So x is considered to be a constant number for the purpose of calculating this limit, of course. Okay, so what I do, of course, from now on I don't expect you to answer this because you haven't seen that. So if I take sine x out between these two terms, so it becomes sine x, and then I will have cosine h minus 1 divided by h. H goes to 0. Okay, sorry, let me continue. And then this is just it. I can just write plus sine h dot cosine x. So that is, I have actually written the same thing in a slightly different form. I factor sine x between these two terms out, and I copied and pasted this one here. But now I have something divided by h. I have the sum of two numbers divided by h. I can divide this by h, divide this by h, and add them separately. Yes, so I can do this. I would write that this is equal to the limit. I write something, if you don't understand, please let me know. I would write it in this form. Is that understandable for everyone? What I explained, I can write it in this form, yes? So I divide this by h, but instead of writing sine x close to it, I decided to write it next to that fraction. The same thing here. Yes, that's the same. Yes. But the point is that sine x and cosine x are constant because my limit variable is h. So the point is that if I can calculate these two limits, then I am done. Yes? If I can calculate these limits are numbers at the end. If I can calculate them, then if I find the correct numbers, I put them back here, then I am done. And this is exactly the part that I told you that we cannot do it rigorously here. So this is a very famous limit. So you see that again I have the same problem. This h is held captive by this sine. And this, there is no way that I can cancel that h with that h. And even if I cannot get rid of this h, I will have always my problem that h goes to 0 and the denominator vanishes. So this, you see, this is a little bit unusual limit. So you need to find another way to find that limit. It's not a way that I can, I don't know, multiply by the conjugate or whatever. Whatever I do, h will remain inside sine. And I cannot make it free to get rid of these two h's in some way. So the only thing that you can convince yourself, either draw the graph of this function using GeoGebra, and you see that when you get closer and closer to 0, the height of this function becomes close to 1. Or you can take your calculator and put, for example, make a table for yourself, h, I don't know, for example, you can start from 0.1, in radian mode. This is extremely important, in radians. You put 0.1 use your calculator and calculate what happens here. You get a number here, and then you make it smaller, and then calculate, you get a number. You make it smaller, and you calculate, you get a number, and then you see immediately that when you are making this smaller and smaller and making it closer and closer to 0, these numbers are getting closer and closer to 1. Okay, but that is of course not a mathematical proof. But then you need to trust me on that, so the answer will be equal to 1. But extremely important, if you switch your calculator to the degree mode, you will get a different number. We will calculate that different number here as well, but this is extremely important. This limit is true when h is expressed in radians. When you calculate this limit in radians. Okay, and then if you do the same thing for this function, this approaches 0. So this is why the formula that I want to calculate for the derivative of sine, what I get and put it there, only works if I am working in radian mode. Because only in radian mode, this limit, even in degree, becomes 0. But this limit in the radian mode is 1. In the degree mode is approximately 0.017. Okay, so that number would be different. Okay, so be careful. Because this is valid in radian mode, the formula that I get for the derivative of sine is also valid in the radian mode. Yes? And then if you trust me on these two limits, then the rest of it is simple. So I will put it back. This becomes 0 multiplied by 0 plus cosine x multiplied by 1. And then this is gone, and then what is left for me is cosine. So it's a very nice relation. If you differentiate sine, it becomes cosine. Yes? So I will take this question mark away now, and now I can put it as cosine x. So if you want to write this table, so let me emphasize in radians. Yes, is that okay? But from now on, this, I told you, this is the only table that you will get in the formula sheet, but the important questions are not that simple. They are related to this. So you need to find the chain rule version of that yourself. So do you remember what was the chain rule version? I told you that in the chain rule, if you take g of x to be u, then this becomes f of u prime is equal to f prime of u dot u prime. Yes? So that is what we had before. And I told you that the only thing that you need to remember is to this extra u prime. So if I ask you, what is the derivative of sine? Instead of x, I put u, a function of x. Okay, can you tell me? I want you to see that you understand it or not. If I ask you differentiate this, what do? You follow the same rule that you have on that table, which is the only table that you get in the formula sheet. So what should I write in front? Yes?
Cosine u times u prime.
U prime. So that's the only thing. So from now on, whenever we learn the new derivative, you yourself should be able to write the chain rule version of that derivative. That is the same rule that you discovered, but you need to remember that you have to multiply it by an extra u prime always. So that is the only thing that you need to remember. So let us do some exercises here now. So I ask you to differentiate these functions. So, example, differentiate. So, number 1, f of x equals to sine of 2x squared plus 5. you want to differentiate this function. Okay. If I want to solve this, this is not exactly I have in that table. In that table, I have sine of x alone. But this is a combination of x, so it means that I should use the chain rule version of this formula that I discovered now. But then you need to take something to be u so that you know what to do. So it is very, very natural, of course, here. What I'm supposed to take to be u here? Yes?
2x squared plus 5.
5. Yes, you don't need to write it, by the way, but let me just write it here. You take this one u in your head. Is it a good choice? Yes. Because now what I have sine of u. And I exactly know what to do with sine of u. So what will be the derivative? F prime of x becomes cosine of u, according to this that we discovered today. But the point is that it is not finished yet. So you have to multiply it by what? The derivative of u. And then you have to continue until you do not have any primes left. So this becomes what? 4x. But instead of writing 4x on the right, I prefer to write it on the left. So this becomes 4x cosine 2x squared plus 5. Yes? I don't know, based of my experience, many people actually make some mistakes here. So let me just now see what do you do here. Yes, f of x equals to, I would write sine to the power of 5, yes, and then I would write 2x squared plus 5. So what I have done, I have put the power of 5 up there, yes, I haven't changed anything. Instead, I put the power of 5 here. I'm asking you the same question. So what is the derivative? I don't know, based on my experience, students make mistake for this problem. Okay, I want to see that you can prove me wrong, yes? So what is this one? What is the derivative of this one? So you need to give me a proper u. So what do you think would be good u? Yes?
2x, or the parenthesis powered by 5.
No, the parenthesis is not, the power of 5 is for sine.
Okay.
Yes, so do you know that when you write sine to power alpha, this means sine alpha to power 5. So you cannot say that you can take this one because 5 is not up here. Yes? So what should I take as u? Yeah, dare to say something. It's not that hard. I said something might be. So what should I take as u?
Sine 2x to the power 2 plus 5.
Yes. Sine 2x, that is a good choice for you. And many students start taking this again to be u. This is not good. Why? Because if I write this u in a scratch paper, you will have sine to the power of u, 5 to the power of sine to the power of 5u. If you take this u in your head, do you agree? But if I ask you, do you know the formula for this? The answer is no. The formula I know is only for sine u, not sine to the 5u. So this is not a good choice right now for you. If this is not a good choice, you need to find another choice. Yes, the whole thing means
Sine.
yes, this expression to be u. Yes? Why this is good now? Because now in a scratch paper you will have u5. But do I know how to differentiate u5? The answer is yes. What's the answer? The answer is 5u, but to the power of 4u prime. Yes? Is that understandable? So that is extremely important to understand. So if you really understand this problem, it means that you really understand the chain rule. Yes? Because even though this is very, very simple, but that is the essence of the chain rule. Yes? Everybody agrees with that? So the first choice was not good because of the reason that I mentioned, because if you choose this one to be u, you will have sine 5u, but sine 5u, I don't have any formulas. But let me take the whole thing here, u, then it becomes u to the 5. Do I know a formula for this? Yes, it is similar to x to the 5. It becomes 5x4. But in x, it is finished there. But if I have u, I have to write 5u4, but it is not finished because of the chain rule. I have to multiply by an extra u prime then, yes? So then what will happen here, it becomes u to the power of 5, and then I use this rule. So the first thing that I do is the derivative f prime of x. Okay, help me to write it. I have a factor of 5. I have u to the power of 4, but I am taking this to be u. So u to the power of 4 is nothing except sine to the power of 4 of that expression, yes? But multiplied by what? Multiplied by u prime. But this was my u. So it becomes sine 2x squared plus 5 totally prime. But then you see that this is exactly the meaning of the chain rule, yes? So now, the process is not finished because I have a prime left. I have to continue, so I have to copy and paste everything. Don't be lazy for that. And I will be lazy to give you points. Yes, but then you take the derivative of this one. Forget about that I have solved the problem exactly here. Now you want to differentiate this one. Which one is a suitable choice for u for this particular function? This u, which was not suitable in the beginning, now is the only choice that we have. Yes? So then it becomes, again, sine u becomes times cosine u. You see, whenever you think it is finished, it is not finished. Another loop is coming. Okay? And then the problem is not finished because there is a prime left. What I do, I would copy and paste everything again. And then multiply it by 4x. And in differentiation, simplification doesn't matter for me right now, but if you want, I can multiply 4 here, it becomes 20. Let us simplify that a little bit. So the final nice form of this derivative, if we can call it nice, of course, is this one. So, and it is very beautiful. Because assume that you wanted to use the definition of derivative to differentiate this. This is not possible. So chain rule is probably the strongest rule that we have, you see. Otherwise, we couldn't find the derivative of this simple function. Yes, I give you one more so that you can solve it for me. Number 3. Let me make it a little bit harder. So, 5 sine to the power of 3 sine to the power. Let me make it 2. Let us see the challenge, yes. And then you have square root of x squared plus 1. So yeah, if you really can solve this, you learned everything. It doesn't mean that if you couldn't solve it, you didn't learn anything. But first of all, let me tell you. So how many functions are involved? Quite many functions here. Yes. You take x squared plus 1, the first function, and then square it. Then take the sine, then square it. All of these are functions. Then you take the sine, then raise it to power 3, and then multiply it by 5. So that's a combination of a lot of functions, except the last one that I am multiplying. Up to here, it's a combination. X squared plus 1 you calculate, then the squaring function comes in, and then the sine function comes in, and then raising to power 2 comes in, and then the sine function comes in, and then cubic function comes in. Yes? So this is a combination of a lot of functions, and you want to differentiate this function. Be careful that, I don't know, some reason some students think that this is a product. That's not a product. This whole thing is playing the role of the angle for the next sine. Yes? That is it. So this is extremely higher than the level of the exercises in the book, but I think it is really important to be able to do that. Okay, so I will pause the video recording the video so that I give you a chance to do it. Make sure that you don't even make one single mistake, yes? Take your time, do it patiently.
Oh, right.
Okay, so let us do something here. What is the first u that I have to take? No, what?
It's sine of sine squared.
The whole expression except that part 3, yes? So if I want to give you this, I don't know what evolution has done to us. We have a natural tendency to take x squared plus 1 as u. This is not good, okay? And the reason is clear, don't memorize that. If I just take this one, at the end you have to take this u, that is inevitable. But if you take this one u right now, you will have 5 sine cubic sine squared square root of u. That complicated function is not in your table, is it? So it means that it's not good. If the best rule of thumb is this, what is the last function is going to apply? Do you remember which function acts first? If I ask you what is the innermost function, you would say x squared plus 1 function is the innermost. And what is the othermost function? Do you remember the order? You calculate x squared plus 1, then the squaring function comes in, then the sine function comes in, and then the squaring function comes in. Sorry, that was a square root function. Squaring function comes in, and then the sine function comes in, and then the cubic function comes in. So the outermost function is the cubic function. Yes? So this is the very good rule of thumb, so that you can take the whole expression to be u first. Why is that? Because then you will have this function. You go to scratch paper, you will have 5 u to the power of 3. Is this a simple problem or not? Yes, it is 5u cubed. Yes? So what you do, you have to take the whole. Remember this rule of thumb. The othermost function is the best, is the first choice for you. Okay, so I will take f prime. Okay, can you tell me what is the answer to this derivative? It is 15 u squared, but it is not finished, times u prime. Yes? So that becomes 15 u squared. You shouldn't be lazy. You need to write all the expression. This is your u that I am writing. This is u, but squared. Yes, 15. The answer to this is 15 u squared u prime, yes? 15 is here. This is my u. This is my u, but squared. Multiplied by u prime. So what should I do? I need to write sine. You don't have to write these things. Of course, I would be more than happy if you do most of it in your head. But for the time being, let me be patient and write everything. So, do you agree that what I have written is exactly according to the rule? 15, this is u to power 2, this is a copy-paste of u prime. Yes? And now, you have to go to the next step, 15, sine, you have to copy and paste everything without prime. X squared plus 1. Yes, and then you need to take this derivative of this one. Now, which one I should take to be u? Forget about this. Don't let this problem distract you. You just forget about everything here. Concentrate here. So what are the functions involved? X squared plus 1, square root function, sine function, squaring function, sine function. So the last one is sine function. So what should I take for u here? This expression should be your mu u. Yes? Why is that? Because if you do not look inside, you see sine u and you know how to act for sine u. What is the answer we learned today? It becomes cosine of u. But it's not finished. Multiplied by u prime. Yes? And now you feel why this is called the chain rule, yes? Then of course you have to copy paste a lot. Now I am asking you to calculate this one again. Don't make mistake. Which one should I take to be u? forget about everything. Don't let these things distract you. This is the simple problem. And by the way, every time that you are solving, you are making the problem even simpler than the previous one. Yes, if you could do this before, you can definitely do this one. Which one is a good choice for you here? The whole sine, exactly. Thank you. This becomes the whole u. Then it becomes u squared, and you know what to do with u squared. So what is the derivative of u squared? It is times 2u, which is this one, but multiplied by u prime. Yes? Again, the copy-paste part starts. Okay, copy-paste part finished. Now what should I take as u? What should I take as u here? A square root, thank you. A square root of this one to be u. So the derivative of sine of that is cosine of that, but it is not finished. Multiplied by u prime. Yes? 2 more steps. So what we have to do, and if you don't mind, let me multiply these 2 here. Make it 30. Sine squared, sine square root of x squared plus 1. And then you have cosine, sine squared of square root of x squared plus 1. And then you have sine square root of x squared plus 1. Cosine square root of x squared plus 1. What should I take as u here? What should I take as u here? This one. And then what is the answer? You have it on the board. It becomes times 1 over 2 square root of u. But it is not finished. Multiplied by u prime. But this we can do it in our head. What is that? 2x. So this expression is your derivative. And I hope that you appreciate the chain rule now. If you want to do this other way around, it is even not possible to calculate those things. Any questions here? So if you really understand this, your differentiation process doesn't have any problems. What you need to do is just to learn new functions. And that is the idea that we want to do. Now that you solve this hard problem, let me ask you one single question. What is coming next, do you think? Okay, can you answer this one? No. So I want to see how do you think about this problem. We want to find the derivative of cosine function. So you see that in these kind of questions, I might give you some bonus questions in this way, but yeah, you see the problems in the book are simple. Here, I care about all the terms that you write for me, but not about simplification. Even if you choose to put t2 here, no problems, because the point is to how to differentiate. Okay, can you tell me what to do with the derivative of cosine function? I want to find the derivative of the cosine function now. So what is your suggestion? Yes? Start from scratch is completely acceptable way, and then you will see I don't need new limits. The limits that was useful for the previous case will also be useful in this case. Okay, so let us do from scratch. Okay, I can write here. So we want to, the function that I am interested now is f of x equals to cosine x. And I want, again, in radians, so be careful. Yes? Okay. I want to calculate the derivative of this function. So this becomes the limit, h goes to 0 here, f of x plus h, I hope that you agree now that it becomes this, and then minus the function. So I have to calculate this limit. Agree? Everyone agrees with that one? Yes or no? Okay, but then again, do you think, what should I do here? Do you remember what I did? I use addition formula for sine. Of course, we also have an addition formula for cosine. So definitely, it is better to use that formula here. So it becomes cosine of x. Do you remember what was the formula? It was cosine, cosine. But if it was positive, I should write negative here. So sine x, sine h. And this negative is because you guess that the derivative of cosine becomes sine. It is not true, it becomes negative sine. And that is exactly because the addition formula of cosine gives you a negative sign rather than a positive sign. You will see why. So it becomes minus cosine x, and then I have divided by h goes to 0. Okay, so if I want to do the same thing, but I want to do it faster, between these two, I can factor a cosine out and then divide by h. I write it in this form, cosine x, cosine h, minus 1 over h. And then I will have minus sine h, sine x, sine h over h. H goes to 0. Yes, is that understandable? I did it very fast because it's exactly like the previous one. Yes? Do you agree with me? And then do you remember this? If you go to your notes, you see that this limit and this limit are exactly the same limits that appeared there. And then I told you that you need to trust me on that. So this limit becomes 0, this limit becomes 1. Exactly as the previous limit. So what will be the answer? 0 times cosine is 0, 1 times negative sine x becomes negative sine x. So the answer becomes negative sine x. So what I have to put instead of this question mark is what? Negative sine x. So be careful. The derivative of sine is cosine. The derivative of cosine is not sine, it is negative sine. Okay, but there is a better way to do the derivative of cosine. Can you tell me how? I want you to give yes.
You can write cosine in terms of sine.
How?
Square root 1 minus sine squared.
So the idea is exactly what you said. That is, I agree with that. But sine squared x plus cosine squared x equals to 1 is not very good. Because if I want to write cosine, it becomes 1 minus sine. Then of course if I want to write cosine, it becomes plus or minus. Yes? Then I have to do it 2 times, one for positive and one for negative, and try to convince myself which one will win at the end, yes? But your idea is completely right. So you wanted to write cosine in terms of sine, but there is another way to do the same idea, but not with the Etan formula. What is that? What is that? No? I don't know, why don't you respect this? Complementary angle. So sine and cosine are not independent identities. So, for example, in physics, I don't know if you have seen harmonic oscillators, some books write it as cosine, some books write it as sine. It doesn't matter, because there is a just pi over 2 shift between sine and cosine. Okay? So, if I want to do this, the idea, I told you, the idea was good, but this is a little bit technical to get rid of these plus and minus signs. We have to consider both of them. But here, if I want to calculate f of x, the derivative of cosine x. But I know cosine x is nothing except sine of its complement. Yes? So if I ask you what is the derivative of this function, forget about this. This is a very, very simple exercise for you by now because you were able to do it yourself. So what can I calculate for this one? If I want to take the derivative of this one, I should take this one u in my head. So it becomes cosine of u, agree? Yes? And multiplied by u prime. But what is u? U is this one multiplied by u prime. Yes? But now what is u prime? Minus 1, yes? The derivative of pi over 2, pi over 2 is a constant, it's 0. The derivative of x is 1, so it's minus 1. And I multiply minus 1 here, it becomes minus cosine pi over 2 minus x. But cosine of the complement is sine. So it becomes minus sine. So that was easier. Instead of doing it again from scratch, that way is actually a very good way, because first of all you understand and appreciate the power of the chain rule, and then you can also review this. Hopefully you will remember it from now on. Sine and cosine of complementary angles is very important to know. So what I put here, it becomes just minus sine x. Okay, so actually this I don't want to teach more. This section is finished, but I want to tell you something. What happens if I want to work in degrees? Okay, so for example, this question I want to answer here. I want to ask you first. What do you think? So, my question is this. Let us go back to the previous function. F of x is equal to sine of x, but I put this degree sign there. And I'm asking you the same question. So, how should I answer this question now? Of course, I want you to know it, but we will never more or less use it, because from now on we will work everything in radians, yes? So, but in principle we should be able to do that, yes? What should we do? No, I want to correct your way of thinking. Why are you thinking so much? The starting point is probably should be instantaneous. Might be you cannot continue after that. That's a different problem. But you want to solve this problem for x in degrees. What you know so far is the derivative in radians. So what is in your hand? You know the derivative of your function if it is expressed in radians. Now you want to do the same thing if it is expressed in degrees. So this is your new problem. You don't know it. You have to reduce it to a problem that you know. This step you need to learn, yes? You are in Math 4 now. And you have Math 5. Some of you Math specialization. But this way of thinking, you should have developed them so far. So what should I do? Tell me, okay? Okay, what is the first step to do? A brave person, yes? What's the answer? What is the starting point? I told you right now. Yes?
That you write the angle in radians.
In radians, yes? And then x degrees means x times 1 degree. Yes? What is 1 degree in radians? It's pi over 180. So x degrees is equivalent to pi x over 180 radians. That's it. So what I would write sine. Instead of x degrees, I would write pi over 180x. But this is now expressed in radians. Am I allowed to use the derivative that I have in table? Yes, because it's in radian. So, but I have to use the chain rule. Because this is not exactly x. So I have to take this to be u. Yes? So if I want to differentiate f, this becomes equal. You have to take this in your head to be u. Yes? And the derivative of sine of u is what? Is cosine of u. But it is not finished. Multiply. Yes? No, there is no degree. Sorry, there is no degree. Sine this multiplied. Okay, derivative. Okay, can you tell me what is the derivative of that one? Everyone, loudly, please. I want to see a different voice. So what is the derivative of pi over 180x? Everyone? Pi divided by 180, yes? Yes? Yes or no?
Yes.
You know, I have been teaching for a long time. I know that some of you didn't guess this. If you are one of those, please let me know. I can fix it, okay? So pi over 80 times x, the derivative of this one, this is exactly like 3x. If I ask you what's the derivative, you immediately answer this 3. This is a number. It's written in a little bit fancy way, but that's just a number. So the derivative of this one is that. Okay, so it becomes pi over 180, but usually we put this here. And cosine of pi 180x. So this is their formula. But if you are a mathematician and a good student in mathematics, do you stop here or not?
No.
So what do you do? The problem in principle is finished, but if you know what you are doing in principle, no good student in mathematics will stop there. I want to hear from you. What is the next step that I want to do?
You get a point if you write them here?
No, these are very fundamental things. I want you to feel them. This is not tricky question. It's a very simple. This is not a natural step point to stop. Yes, Ruben?
Convert back to.
Exactly. Why don't you say this? I started with a problem in degrees. I am answering you my answer in radians. This is not very normal, is it? So you have to go back to the names first. Thank you very much. So this becomes f prime of x pi over 80, 180 cosine of, what should I write? X degrees. And that is also another reason that we want to work with radians. Otherwise, we have to, we have to keep these kind of fancy constants all the time with us. Yes, pi over 180. So if I give you the sine function in degrees, the derivative is again cosine function, but with an extra factor. And this extra factor is a little bit annoying. So let us work in radians. Yes, is that understandable? Yes or no? Okay. And then what do you think would be the derivative of this one? Now you guess. You don't need to calculate. So if I give you this, what is the derivative here? Positive or negative? Negative. So it becomes negative what? Pi over 180 sine x degrees. Yes? So if you, so I want you to know that was not hard, but we never, more or less, almost never work in degrees from now on. But it doesn't mean that we don't know how to calculate it. Okay, so let me pause recording to see if there is something in the book that I have not